Let's look at the distribution also over here. So over here you can select either the box plot only. You have other options also. Most probably we'll be exploring box plot and histogram. Okay, because that's what you have learned in your curriculum. The cumulative frequencies, if you are interested, you can do that. The Benford analysis also you can do if you want. Again, you'll have to Google and find out a little bit about the theory of the same. So I'm clicking on Indus crime and pressing and execute just for the first run. So you can see this output on your plots. You can see the distribution of crime, distribution of Indus, LSTAT, MEDV. These were the variables which were selected. So you can play around with this. Say for example, I'm removing the box plot of these variables and just keeping it for MEDV and histogram also I've added additionally, and I'm pressing execute. Right now these are two different types of plots, so obviously what would have happened is that they don't come parallelly, they come behind each other. So you'll have to just browse it from front and back, say next and previous, and have a look at that. Because we have not done the bifurcation using the partitioning function, which you would have done manually when you're using R. So when you do manual coding, you have a little bit of more control on how you want to look at things. Okay, let's explore a little bit more. Let's say cumulative for MEDV. Let's execute. We'll show you the distribution from a cumulative frequency perspective. Removing this as well. Now you would like to do a group by also, but obviously there is one challenge: we don't have any factor or categorical variable, so because of that it will not be populated. So that's one challenge for us. So maybe if we can transform the data later and have a look at how it will look when. So although CHAS is a good candidate for looking at how do the variables look, but in this case we might not see any value, or it might not even allow us to select that variable in the group by clause, because it is not a class based data. It's a continuous data from a perspective of the data type. So any effort to keep on changing the parameter also won't make sense, because functionally it is not making any sense. There could be a possibility in some other package wherein this is automatically handled. This could be seen. We will look at that when we look at the interactive charts, wherein even if we don't have it as a class based data, we might be able to see that aspect because it can handle it better than this. So we have an option wherein we can transform, but let's not do that as of now. We'll cover the transformations when we actually look in detail into the transform tab. Let's move over to the correlation aspect. So we can look at the correlation. There are different options over here. We can just select the type of correlation, Pearson, Kendall, Spearman, depending upon the type of data. We have mostly numerical data over here, so we can use the default Pearson. It would expect us to install this core plot package, so just do the installation. Okay, so you get this chart. We have done this manually also, but this is about doing it through the GUI. Yeah, this is the table, the correlation chart. If you had class-based data, you could have selected over here the Spearman correlation coefficient.